Okay, this is going to be 5-3, which is named polynomial functions. Like I said, we're going to take 2 days on this guy. We kind of get into more details about polynomials in this lesson. We go back to evaluating some functions with them and other sorts of things. Okay, so more so today is more computational. Tomorrow is going to be more conceptual. All right. First slide, though, we have a bunch of. There we go. Whoop, back up. There we go. Okay. Polynomial in one variable. Its definition is quite ugly. All right, if you look at it. All right, definition, polynomial in one variable. Expression of the form blah, 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 where a sub n does not equal 0, a's are real numbers, and n is a non-negative integer. Basically what this means is you have a polynomial that's in one variable. You have stuff that you've done. Okay, like last lesson from the synthetic division chapter or section. 3x to the fourth plus 2x to the third minus 6x squared plus 3x minus 11. That's a polynomial in one variable. All right. Your exponents are non-negative. The leading coefficient's not 0. They're all real numbers. Okay? So that's what a polynomial in one variable means. You don't need to write this malarkey. Okay? Just write down this as example. Alrighty? Make sure you do, however, write everything else down pretty much word for word from this here. Okay? Because it's all important. Alright? The polynomial is written in standard form when the values of the exponents are in descending order. So if you remember from 5.2, when you're doing your synthetic division, every single one of them was in standard form because it went from the fourth to the third to the second to the first to the none. Okay? Or from the third to the second to the first, or from the fifth to the fourth to the third to the second, so on and so forth. That's considered to be standard form, and 99% of the time, you want your polynomial functions to be written in standard form. Okay, so if it's not written in standard form, chances are you probably need to make it written in standard form. Going descending from biggest exponent down. Okay?
Wait, so what if it, like, isn't in descending order?
You just move the terms around so they are. Okay, and leave the sign. We'll do one like that in a little bit. Alright? Everybody good so far? Okay, now the two major definitions that are going to come from today are the two that are up on the screen right now. The first one being degree. From here on out throughout this chapter, you're going to hear me say this word degree. I'm not talking about the deodorant. I'm not talking about the temp outside. What a degree is the value of the biggest exponent. The greatest exponent. So the one I wrote up top, the degree would be what? 4. Okay, the biggest exponent, whatever it is, that's what a degree is. And the way I'm going to say that is, what's the degree of that polynomial? Just like it's written up there. Okay, degree of a polynomial. Alright. Your second definition is called leading coefficient. The leading coefficient is the coefficient, which these are all coefficients, yes, everybody? The 3, the 2, the -6, the 3, the -11. Yeah, everybody either know that or just learn that. Okay, everybody good? The leading coefficient is the coefficient of the term, of the first term of a polynomial in standard form. Whoop. Boom. So the degree is your biggest exponent. When you write a polynomial in standard form, you write it from the biggest down, which then means the first number is this thing called the leading coefficient. Make sense? Okay. Now, what we're going to do with that today, we're just going to find them. That's it. Okay, and that's where this lesson kind of goes. It kind of goes a little weird because we're going to do this. We're going to talk about these two terms. The rest of the day, we're going to actually go to something else, and then tomorrow we're going to pick these back up. Okay, so it's kind of a little bit of a weird setup with this chapter today. or this section of this book because I don't know why they want to do it this way, but whatever. Okay. The box down here is kind of just more examples than anything else. Okay, so you don't necessarily need to write this, but like they show you different examples. For example, this one here, you have 8x to the third plus 12x squared minus 3x plus 1. It tells you your degree is 3, your leading coefficient is 8. 5x squared minus 6x minus 9, degree is 2, leading coefficient 5. So they're just more examples, nothing really there. Okay, so we got a few examples here. We're going to state the degrees and leading coefficients of each polynomial that's in one variable. So first thing you do, double check, make sure it's written in standard form. Okay, like I said, 99% of the time you want them in standard form. Most of the time they'll be given to you in standard form, but just double check. So make sure you go from your highest down in order. So 5, you can skip 4, that's cool. So 5, 3, 2, 1, none. Cool. The only thing you really care about, though, is the first term. Okay, so the degree of this guy is the biggest exponent, which is 5. And then the leading coefficient is the number that's attached to it, which is 8. So everything about this comes from this first term. Now the second one, you have 12x squared minus 3xy plus 8x. I got a question for you. Is that in one variable? No, it's got two variables, so you don't even worry about it. Not in one variable. The book likes to throw a few of those at you. I won't. Okay, so you just write not in one variable when the book wants to be mean to you. See how you have an xy term right here? Okay? And tomorrow you're going to realize that all of these graph. Okay, we can graph these. If you have multiple variables in there, you can't graph them. Okay? That's why we only care about the ones that are in one variable, because those actually graph. Okay? The third one down here, we have 3x to the fourth plus 6x cubed minus 4x to the 8th plus 2x. Okay, so I have a question. Is it in standard form? No, it's not. All right, now, you should probably move it to write it in standard form. You don't have to for this, though, since all we want is the degree and the leading coefficient. But you have to be careful. Okay, so let's start with the degree. All right, the degree of that guy, remember, is the biggest exponent, which is going to be 8. Okay, 8. Now, my question is then, what's the leading coefficient? So what is it? -4. Okay, the leading coefficient is going to actually end up being -4. Because remember what the leading coefficient is. It's the leading coefficient, it's the first one, when you're in standard form. This guy's not in standard form. So if you rewrite it as to be in standard form, and your biggest exponent's going first, it'd be -4x to the 8th. Okay, plus 3x, yada, yada, yada. Okay, so be careful when they're not written in standard form, okay? Okay, so same concept with function evaluations. Find 2f of 4y if f of x equals x squared plus 2x minus 3. Xavier.
Do you have any paper?
So we're going to do the same thing. We're going to take this 4y, and we're going to plug it into the x's that are in f, right? Into there and there. Okay, so we're going to set this up. Equals 4y squared plus 2 times 4y minus 3. Okay? That's taking the 4y, plugging it in. Now, what are we missing still? The 2. What does that f tell us? That f tells us what? Okay, let me ask it like this. On the problem we did on the board, did the f matter? Did f show up in our answer or anything? No. It just tells you which function you're using. So we know we're using f, so the f is really irrelevant. So we're taking, so what do we still need to write up there? The 2. What's happening with that 2? What's it being done? Yeah. Okay. You're going to end up distributing that 2. Okay? Because you do f of 4y first, and then you double that. The black in here is f of 4y. The blue 2 is distributing that 2 through. Everybody good? Now I actually simplify. So what's 4y squared? 16y squared. There you go. Okay, 16y squared. What's 2 times 4? 8y minus 3. And last step, like Xavier said, distribute a 2. So 16 times 2 gives you 32y squared plus 16y minus 6. Okay. F of 3c minus 4, if f of x equals x squared plus 2x minus 3. This 3c minus 4 goes in where? For the x's. Okay, so right there and right there. So we got equal. 3c, whoops, not 36, 3c minus 4. And what's being done to that? Squaring. Plus 2 times 3c minus 4 minus 3. Okay, that's the correct setup. All right. Now, I got a question. What's 7 squared? 49. How'd you get that? 7 times 7, right? Okay. 7 times 7. What's 3c minus 4 squared? Nope. Hmm? Nope.
3c minus 4.
Nope. What's that square? That's what I'm asking.
Oh, what's it square?
Mm-hmm.
Oh, yeah.
Close, but no. That's the most common. Okay? Here's what everybody wants to put. All right, I'm doing it right because it's wrong. Everybody wants to put 9c squared plus 16. And it's wrong. Why is it wrong?
You don't have x.
That's okay.
Can you square it after?
It'd be negative 16.
No, it's positive.
Can you square
Negative 4 times.
When you do 7 squared, what do you really do? 7 times 7. So when we do 3c minus 4 squared, what should we do? Multiply it by itself, which would be 3c minus 4 times 3c minus 4, which is going to become what f word? The circles got smaller, that way I can just do that. You have to FOIL a squared binomial. Have to, okay? Because it's 3c minus 4 times itself, so you FOIL it, all right? Everybody gets that at first wrong. And you're going to be close, okay? If you don't FOIL it and you do what Sydney said and just put 9c squared plus 16, you got 2 of the 3 terms. Because 3c times 3c gives you 9c squared, just like the first time. Negative 4 times negative 4 at the end is going to give you plus 16, just like the first time. But you miss your O and your I. You miss your middle 2. So what's 3c times negative 4? Negative 12c. What's negative 4 times 3c? So 9c squared minus 24c plus 16. That's what goes up here for this. Okay, let me make that all smaller. Everybody good? Understand what I'm saying with that? Simplify. But yeah. Okay, so equals 9c squared minus 24c plus 16. What do you do with this 2? Distribute the 2. So plus 6c minus 8 minus 3. Now you go through and do what? Like terms. So 9c squared, 24c, and 6c gives you negative, should be 18, right? 16, negative 8, negative 3. Alright, let's find out. So we're plugging in 5a minus 2. Gets squared minus 5 times 5a minus 2 plus 8. Okay, now here is where I know how to FOIL, and I know how to FOIL really well. 5a times 5a is going to give me 25a squared. The middle 2 both time are give me negative 10a, so that's going to give me a negative 20a when I add those up, and then plus 4. So all of this is this guy FOILed. Okay? Make sure you FOIL. It's like the most important thing to take from this lesson, to be honest. Alright? The negative 5, you what? You distribute it, so you get negative 25a plus 10 plus 8. Okay, so let's get some like terms. We got 25a squared all alone. We got negative 20a, negative 25a to give us negative 45a. And then 4 plus 10 plus 8 gives us what, 22? Page 326, 14 through 34, evens.